All right. So continuing on here, we found our missing angle, and now to find our missing sides, remember that anchor of the 44 degrees across from side A of 16 is what we'll use in each of our proportions to solve for our missing sides. So I'd have that 16 over sine of 44 using our law of sines, and then anything else. So like I can use the 54 across from my unknown of side B. And then remember, we had a way of solving this that we just needed to multiply by sine of 54 on both sides. Hopefully you're kind of used to that by now. B is going to equal whatever I get when I type in my calculator, 16 times sine of 54 divided by the sine of 44. Just kind of consistently throughout this chapter, we will always round our sides to the nearest tenth and our angles to the nearest degree. And that one should have come out to 18.6 for that missing side length. And similarly set up to solve for C, again, use the angle and side across from each other. So I'm going to use that 16 across from the 44 degrees again. And to solve for C across from 82 degrees. Multiply both sides by the sine of 82 to solve for C. And type in my calculator 16 times sine of 82 and divide that by the sine of 44. And I believe that comes out to 22.8 degrees. And again, always keeping things relative to what we know about triangles. The longest side should be across from our largest angle, shortest side across from our smallest angle, etc. That just gets us back into how we use law of sines. Today, we're going to expand this a little bit. One of the things we have yet to use law of sines for is to solve for an angle, but we can do that, okay? So that's one of the things we're going to learn today. The other thing is what's called this ambiguous case. And what it turns out is there is a type of set of information given to us in which we are actually not clear whether or not it makes a triangle or one triangle or actually even two triangles. And we're going to take a little quick trip back to geometry to look at that. So on our second day of law of sines, we're going to get introduced to this ambiguous case and also how we can use our law of sines to solve for an angle. So trip back to geometry. I don't mean to bring up any bad feelings here, but back in geometry, you guys did proofs. And I know it's not everyone's favorite, but we kind of need to revisit that for a second. In proofs, in geometry, you were allowed to use side, angle, side, 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 angle, angle, side, angle to prove that two triangles were congruent, and they never let us use this side, side, angle, or angle, side, side. As much as we wanted to write angle, side, side all over our geometry papers, we were not allowed to do that. And there is a reason why. It does not actually prove that those two triangles are the same, because I'm going to show you that you can actually draw two different triangles if that's the information you have. So what we've been looking at so far with our law of sines are these two last ones over here, angle, angle, side, and angle, side, angle. But actually, given this piece of information here, side, side, angle, sometimes we will be able to find the missing information for a triangle. But what it turns out is it's not always just one triangle. Okay, so why back in geometry were we not allowed to use the one we wanted to so bad, which is angle, side, side? Well, this is a visual representation of why that is not a way to prove that two triangles are congruent to each other. If you look in this picture, I have a 39-degree angle adjacent to a 41 unit side length and opposite of a side length marked as 28. However, because I have no other information, depending on which way we swing that 28 length side, I can actually draw a picture of two different triangles. And that's why I can't prove that they're congruent to each other using side, side, angle. But using our law of sines, I can solve both of these triangles and find our missing angles here, our missing angles here, and our missing sides here. And what I end up with is just being able to find two different possibilities of triangles given this information. So how do we decide if that's what's going on? Well, it is just this. Given two sides and one angle, one of those sides is going to be our opposite and one of them is going to be our adjacent. If the opposite side is longer than our adjacent side, we automatically have one triangle, and I could have given you this problem on Monday and you would solve it just like any other triangle. We wouldn't even have to think about it. Okay, so what we're going to end up doing is comparing our opposite side to our adjacent side. Is going to be our entire process today. So let's look at some other options. Okay, well, what if it's not longer? What if it is shorter than our adjacent side? Well, if it is shorter than the adjacent side, what we end up having to look at is the height of the triangle. I have the height of the triangle right now marked with this dotted line and seeing what happens based on the three possibilities. So once you have decided that your opposite side is shorter than your adjacent, we look at the height of the triangle. If your opposite side ends up being shorter than the height, you can see a visual right there, you can't even make a triangle. There is no triangle to make. You move on, say no triangles. If yours is the same as your height, you get a right triangle as you see here. There's one triangle and we find it like normal. This last case over here is going to be what's called, referred to as the oops, I can't spell here, ambiguous case. And the ambiguous case means that you end up with two triangles. Okay, and we'll end our day with that because that's our brand new information. Either of the first two situations, you will approach finding the rest or solving that triangle just like you would have with our first lesson. So let's look a little bit closer at this. In the notes packet I gave you, you have a flow chart. And in that flow chart, it asks us to identify the height of the triangle. So what I want to do is look at this triangle. Now, not looking at this as a right triangle, we are going to be given angle theta. We are going to be told to a opposite side and an adjacent side, and it does not matter which one is the adjacent side. But I want to show you why I'm calling this the adjacent side. If we were to draw in to find the height of this triangle, what I kind of do when I draw that in is I create a right triangle where this is the height of that blue triangle, but step back and look at it as this purple triangle. This actually becomes the opposite side, and this actually becomes the hypotenuse of that little purple triangle, in which we would use the sine of theta to be opposite over hypotenuse, which in our blue triangle is the height and the adjacent side that we had marked. Okay, so how do we find the height of our triangle? Well, it's that sine formula where your opposite side is really the height of the bigger triangle. Your hypotenuse is really the adjacent side. Solve for height. This is where this formula is coming from. The height will equal what we have identified as the adjacent side times the sine of the one and only angle that we are given. So I just want to show you where this is coming from. It's not just some magic formula. But in your flow chart that we're going to fill out here in just a second, it says the height of our triangle will come from taking what we identified as the adjacent side times the sine of the angle that we have. And this is why. Okay. All right. Find that flow chart. Let's fill that out. Okay. First of all, I cannot stress this enough. If you notice, I made it really, really big. We will only ever need to consult this if the information given to us falls in the order side, side, angle. And if it's been a while since you've thought geometry and side, side, angle, that means that the sides that we are given information about, it doesn't matter where you draw them, but it is not talking about this angle right here, but that our angle theta ends up being not between the two sides that are given to us. This is what's called an included side. And in side-side angle, you are given the not included side. Or sorry, angle. Okay, so it has to look like this, where the angle that is given to us is not falling between those. Now, how can I figure that out? Well, when you are given your list of information like angle A, side B, etc., is that you will have a side opposite an angle, meaning you'll have a set of letters that match. Okay, that's how you'll know that you have one of those opposite sides, making it a side-side angle. Okay. So we've decided that it is a side-side angle. We are now going to identify which of our sides are the opposite and the adjacent and start comparing them. This flow chart, if you understand how to read it, can become priceless to you. So the first thing you're going to do, step number 1, is compare the opposite to the adjacent. That's this level right here. When you can compare them, one of two things will happen. Either your opposite will be greater than or equal to your adjacent. If that happens, you have one triangle proceed like normal. The other option is your opposite is less than your adjacent. And then that's where our new work comes in. And this is new to us today. Okay. We decided that our opposite is less than our adjacent. Our next step, follow the flow chart, says to find the height of the triangle, which is that formula that we just did on the last page. Adjacent side times the sine of our angle. And then we proceed to compare the opposite side to the height. And 3 things can happen. It can either be greater than your height, equal to your height, or less than your height. And so that tells us how many triangles can be created based off of the given information. If we decide ultimately that our opposite is greater than our height, we will have 2 triangles that can be created, and I will show you at the end of our notes today how to find both of those triangles. If your opposite is equal to your height, let's do the middle one, you have 1 triangle, proceed like normal to find. Just like we did on Monday. If your opposite is less than your height, you stop. You say there are no triangles that can be formed. There is nothing to find. You move on. You just say no triangles. Okay. All right. So this is our new thing. Keep this handy as we work through today, because we are going to follow this flow chart over and over. I will be flipping back and forth to this over and over so that we can continue to consult our results of comparing our sides. So first thing is just easing our way into this. Determine whether there are 0, 1, or 2 triangles that can be formed. They're not asking us to actually solve those triangles yet. We're just deciding how many triangles can be formed with the given information. Here is my suggestion for you, is draw a triangle. Mine will not be to scale, ever. I draw mine the exact same way every time, so I don't want you to be like, well, that doesn't look like that would work. I draw the same triangle every time. The entire reason I am drawing this is to decide what side is considered opposite and what side is considered adjacent. So they tell me that angle A is 73 degrees, that side A is 24, and side B is 28. And I can see from my picture, which you should be able to also identify from the lettering, is that 24 will be the opposite side and 28 will be my adjacent side. And so now we go to our flow chart, and our flow chart says compare those. Compare the opposite side to the adjacent side. My opposite being 24 and my adjacent being 28. Well, 28 is greater than 24, so I would say that my opposite is less than my adjacent. Are we all okay with that so far? Okay, so then I go to my flow chart, and this is why I want you to have your flow chart handy. I go to my flow chart and I say, okay, on here, where does it say opposite is a less than adjacent? Well, that's right here on my flow chart, and it tells me what to do now. It says, okay, the next thing you're going to do is identify then the height of your triangle by taking that adjacent side times the sine of your angle. So let's go back and do that. I'm sorry, I have to flip back and forth here, but now it says to find my height. So the height will equal the adjacent side, which is 28, times the sine of our angle, which is 73, and I grab my calculator and I type that into my calculator. Again, making sure that I am in degree mode. And you should come up with, let's see, what is this one up? 26.8. And in that flow chart, it says, okay, now compare the opposite side to the height. Well, my opposite side is still 24, and my height is 26.8, which tells me that my opposite is less than my height. So if I go back to my flow chart, look at your three options here. My opposite greater than my height, my opposite equal to my height, my opposite less than my height is what we just came up with. And that tells me that this makes no triangles. So answering the question, does our information make 0, 1, or 2 triangles because the opposite is less than the adjacent and the opposite is less than the height? I would say that there are 0 triangles. Questions so far? Please unmute and talk to me or put in the chat if you have questions. Okay, so we do the same thing for the next one. Again, the lettering should be able to help you identify which one is the opposite side, which makes the other one the adjacent side. But if a visual helps, draw a visual. And again, guys, I do not draw my triangles to scale. I will draw the exact same picture every time and then just put those numbers in there. So you may see like an obtuse angle drawn and what's clearly an acute angle. I am not trying to draw these to scale. I am just trying to give myself a visual of what is opposite and what is adjacent. Okay, and they don't have to be listed that way in order. So just make sure that you are paying attention to that in your picture. Okay, so using our flow chart, it says compare the opposite side to the adjacent side. My opposite side is 27, my adjacent side is 28. So 27 is less than 28, therefore my opposite is less than my adjacent. Again, if we go back to my flow chart, that is this second line here. So again, we're here, which says go find the height, your adjacent side times the sine of your angle. So that's my next step. Okay, well, the height of this triangle would be the adjacent side times the sine of our angle. Again, in degree mode here, that comes out to 26.3. My flow chart tells me to compare my opposite side to the height. My opposite side is 27. My height is 26.3. 27 is greater than 26.3. Therefore, my opposite is greater than my height. So if I consult my flow chart, the option that says opposite greater than height is here. I have now decided that there are 2 triangles. And again, that's all this part was asking me, is to decide how many triangles. So because opposite less than adjacent, opposite greater than height, I know that this will create 2 different triangles. Questions? All right. So that is the start to this. Remember that if it is 1 triangle, we proceed like we did on our first lesson. So on this one, it says find all solutions for the given triangle. Now, when it says all solutions, it's opening the door for the fact that you could have 2 different triangles that you need to solve. And it also says if possible, because we might find out today that there are no triangles created by the information given. Okay, if it says, we just found out that there's no solution exists, right? No solution, because obviously you can't go find a triangle. Round the side lengths to the nearest tenth and the angle measures to the nearest degree. So again, I'm going to start by drawing myself a picture of what's going on, not to scale, but just so that I can help visualize and make sure that we are looking at a side-side angle picture, because remember guys, if it's not side-side angle, we don't have to go through this work, right? This is the key. Side-side angle is the only time I have to consider this. Well, I see that the 18 is my opposite side and the 25 is going to be my adjacent side, right? So job number one, compare opposite to adjacent. 18 and 25. My opposite side is less than my adjacent. And so then I go back to my flow chart, which is why I want you guys to have this handy. Just have it sitting next to you the whole time. My opposite is less than my adjacent. Go to that part of the flow chart. That line points you to finding the height of the triangle. And so the height would be the adjacent side times the sine of our angle. And I get that the height is 22.3. Compare the opposite to the height. 18 is less than 22.3, therefore my opposite is less than my height. I look at my flow chart. Opposite less than height tells me that there are no triangles. And so I follow what the directions say, and it says write no solution. There are no triangles to go find because the information given to me would not even draw a triangle. Questions? So obviously different than what we did on Monday, because at this point we are not going to go find angle B, angle C, and side C because this information can't even make a triangle. So there's an example of a difference. Okay. Next one, again, same exact directions here. Find all solutions. So let's, again, give ourselves a picture of what's going on here so we can identify, make sure that we are looking at a side-side angle. And again, that tells me that the 73 is going to be my opposite, the 55 is my adjacent, and our flow chart tells us to compare the opposite to the adjacent. 73 is greater than 55. And because 73 is greater than 55 on our flow chart, that tells us that there is one triangle. We don't even have to figure out what the height is, right? That is not necessary on that part of the flow chart. Opposite greater than adjacent says one triangle. Go find your one triangle. Okay, so this is going to be new to us today, is that we are missing this time two angles and a side. So at the end of this, we will have angle B, we will have angle C, and we will have side C. So a little bit different than what we've seen before. The angle across from the side will be this A angle of 105 with a side of 73, and the only other piece of information we have is side B. And so I look at what that's across from, and that would be across from angle B. So that tells me the first thing that we're going to have to solve for here is angle B. So our setup is going to look very similar than one I know, 73 over sine of 105. And 55 across from sine of angle B. And there's our first difference, is our unknown is our angle, not our side length. So please follow closely on this first example of solving for an angle. It's going to be a little bit of a get to know our calculator also. But what I'm going to do is I'm going to look at our cross multiply method here. And so I would have 55 times the sine of 105 equals 73 times the sine of B. And what happens is there's just a little bit more steps in solving for our variable B this time. First step would be to divide by 73. And so that puts us at the sine of B equals 55 sine of 105 over 73. And guys, I'm going to try to help us out and really streamline this. I'm still trying to solve for this variable, which means I need to not have sine next to it, right? Well, it's been a while since we've done this, but to do the inverse of a trig function, what I would be doing is taking both sides and doing the inverse sine. And these will cross off and I will be left with angle B. So that is why I will be taking the inverse sine of, and you can have typed this into our calculator. But I'm going to save it all for right now. So I just type in one time here. So I'm going to go share my calculator with you and get that typed in. Give me just a second here to share my calculator. And again, we will look at it in two different ways here. All right, so to do this, we're going to hit second sine to get that inverse sine. And my calculator is the nice one where I can hit alpha y equals and insert a fraction at this point so that I can just type this all in at one time. And it was 55 sine of 105 over 73. Oops. Got a couple extra numbers in there. And I'll hit enter. Okay. Now there are some options too. If you had typed in the fraction first, you can do the inverse sine of that and just round it or use your calculator to enter that in. But guys, this is really the easiest way, I think, is if you can just save typing it all into the very end here. If you do not have the fraction option, I can go inverse sine of 55 sine of 105. We just need to make sure we absolutely close that parentheses before we hit divide by 73. Again, will give us the same answer there. This is a angle, and so we will round this to our nearest whole number. Please let me know at this time if you're having any trouble getting that in your calculator. Otherwise, I'm going to go back to my iPad and we'll keep going with this example. Okay, so what did we get there? 47 degrees. And again, reminder that that means we now just found 2 out of the 3 angles in that triangle. So to find angle C, we're going to take 180 minus 47 minus 105 to find our third angle always. And that comes out to 28 degrees. And then we know an angle across from our last missing side here, and we can set up law of sines like we would have on our last lesson, which we would use that 73 over sine of 105 equals our missing side C over sine of 28. Solve for C by multiplying both sides by sine of 28. And again, in my calculator, I'm now going to go type that fraction in, 73 sine of 28 over sine of 105. This is our smallest angle, so I should expect our shortest side, and we do get 35.5, rounded to my nearest tenth. Okay, so first of all, big change today is this whole process here on how to solve for an angle. I am going to again post these, but you have to make sure that you're practicing, look back at our notes, watch the video again, etc. All right, we got to get into our last little part here, and that is when we have 2 triangles. So I'm going to skip on these examples a little bit of the information, and that is the whole checking to see if there's 2 triangles. The problems are going to start out by just saying there are 2 triangles, go find them. But this is what's happening. When I have, let's see if we can follow this here. The two different triangles that can happen in this picture would be the green one and the blue one, if I were to swing that opposite side in to create the two different triangles. Well, what happens is, in law of sines, inverse sine is only able to find an acute angle, which will always be this one. This will always be the first angle it finds for you, is in the green triangle. Now, because we are swinging this opposite side in, that opposite side is the same length, whether it's swung to the right or to the left, which creates an isosceles triangle, which you see happening over here. And so what I'm reminding you of is, in geometry, isosceles triangles have congruent base angles. So whatever we found for this first angle is the same over here. And that two angles next to each other that you see in this picture over here, two angles that are next to each other are a linear pair. And so that's how we will always find the first angle for the second triangle, is these two will be a linear pair to each other. And so that's how we get from the first triangle to the second triangle. And hopefully that'll make sense as we go, but that is why I am doing what I'm doing. Okay. I am skipping the part at the beginning that we've decided that it actually is two triangles by comparing our opposite to our adjacent and our opposite to our height, just to save time. But I would start by just giving myself, again, a picture of what's going on. Here's triangle ABC, not drawn to scale. I just draw this out of habit the same way. Okay. I would have done the work to say, okay, what's my opposite compared to my adjacent? And that in this case is my 18 compared to my 24. Well, my opposite is less than my adjacent. I would have gone and found the height of this triangle. And just to speed this up, your height ends up being 17. Opposite compared to your height then, oops, 17 is greater. Therefore, there are two triangles. Okay, that's the work we're kind of skipping. I just flew through that, but they told us there was two triangles. Great. My work on the side just proved that. So what happens is, from this same information, we get two triangles. So we have over here triangle number 1. And over here would be our solution for triangle number 2, all with the same information. Now, in these two triangles, you're finding the same three things. You're finding angle B, angle C, and side B. Okay. Well, over here, to show the difference, we call it B prime. That's not a super important thing, but I want you to understand that that is just kind of a way to distinguish the two different pieces of information that we are finding. Okay, so let's start. Just start with triangle 1, start with the given information and let it guide you to what you can do. Well, what we can do is use the 45 across from the 18. And actually, it looks like we're going to be finding angle C first, because that is across from the side we know. So I'm going to be finding angle C first. Use what I know, which is 18 over the sine of 45 will equal 24 over the sine of C. And this is what we learned how to do on the last page, is I do my cross multiply. I'll show that again. That I will divide by 18. And then we will do the inverse sine to find our missing angle here. So let's type that in real quick. Just a side note, while you guys are getting this typed in your calculator and double checking that you are getting the same thing I am getting, is that if you ever go to type this in and it gives you an error message, there might be a possibility that you need to go back and reconsider whether or not you even have a triangle. Because if it doesn't make a triangle, it can give you an error message at this point. Okay, I'm rounding this to my nearest degree. I have 70.5287, which rounds to 71. All right, let's pick something to like super highlight this in. What color should we pick? Green. This is the key to bridging between the two triangles. The first angle you find, which based on our information was angle C, these two would be a linear pair or supplementary to each other. And so to find C prime, I will always take 180 minus the one I just found. Make a good note for yourself on that. Once you find the first angle for triangle 1, to move to triangle 2, you take 180 minus that. So 180 minus 71 is 109 degrees. Okay, let's move back to triangle 1. I'm going to go ahead and complete triangle 1. To get this, we now know, because that's our last angle, we know 2 out of the 3, so 180 minus 45 minus that angle C that we just figured out, which is 71, and that comes out to 64. And then to find B, we do again use this always for everything in this entire problem. 18 over the sine of 45 equals side little b over the sine of 64. And that should come out to 10.2. Okay, so what you just found right here is one of your two triangles. So this information right here would be option 1. Okay, option 2, we have one angle in there. And again, we proceed like normal. So let's keep going over here to find our last angle. It's 180 minus 45 minus 109. A lot of times, guys, this can be a very small angle, like very small, and that's okay. So we get 26 degrees here. And then again, to find our last side, we again always use the 18 over sine of 45 because that is the information we have in this triangle, right? That is our solid information for this one. And our side B prime over the sine of 26. Do our cross multiply here. Let me double check my numbers on this one. And it looks like 11.2. Ooh, I might have, do I have a typo here? Let me double check. 18 sine of 64 over, oops, sine of 45. Oh, yes. Thank you for catching that. For side B, let's roll back here. I just typed that into my calculator incorrectly. Should have been 22.9. Okay, so there is our second triangle. Second set of information. All right, guys, here's what we're gonna have to do is I'm gonna extend your deadline because we are running out of time, so we're not gonna get a second round of that, of being able to see that. But your assignment is number 31 on my math lab. I'm going to go change the deadline on that so that it's not Friday, but Friday what we'll do